1985b. So we have a ball A moving along a horizontal plane with a speed of u and hits off a pool cue or some sort of inclined plane there. What we need to do is make sure the plane is horizontal. So I'm going to rotate clockwise by alpha, so the line BC will be horizontal like so. And when you do that, then if that's going horizontal, everything rotates clockwise, so it'll end out along that diagonal there. Now I have the speed. I know I've rotated it through clockwise. So what I've done there, look, as I've said, that's alpha between the line that that thing is making and the inclined plane. So the line that the ball makes and the plane is alpha. That's an opposite angle there. So I've got my angle, or that's an alternate angle with respect to that one. Or you could say that and that are corresponding. Either or works. Get the initial velocity vector in terms of I and j. So u cos alpha I minus u sine alpha j. And just like with the previous question, we need to identify which component stays the same and which changes. So that ball would bounce back like that. So the j component changes, the I component stays the same. Look, I component is the same. To get the j component, it's going to go in the opposite direction, and we multiply the j component by e. So change the sign, put an e in front of it, and that gives me the j component. Now, that's the first part done already, because we know now the j component, which is the component perpendicular to that plane there, is going to be eu sine alpha. So that was the first part of it. The second part then was the impulse. So the impulse is mv minus mu. Take that velocity vector, subtract that by it, that from it, and then multiply by m. Gives me this. And because we're looking for the magnitude of it, we can drop out the j vector out of it. Just don't forget the units.